Okay, hi and good morning everyone. So for today I would like to discuss about the part number 2, chapter 6, digital video technology. Okay, now let's get started. In the last video, basically we did cover the history of video technology and filming, and we did discuss about the brief idea of how was the videos and films are related to. So for today, basically we will talk about the remaining parts of the chapter number 6, whereby we will talk about this compression. So compress, for the roots is compress. Okay, the video compression is happening in the same way as what we did discuss in audio and images at the previous chapter. So but the thing is, the compressions it happen in video has, and the strategy kind of compared to this one. So since the video itself remember last week we did discuss about the what they call it, frames, images and picture, you would say. So the context over here is basically for frames. So the sequence of the frames makes the movement of like this is happening. Okay, so if I go by my own, static is an image over here, but when I move my hands, it could be sequence of frames producing the shot of video. Okay, right. So the most important things on the video compression is to remove. Okay, so this will be the keyword obviously in compression: redundancy and extraneous information. Okay, within one frame. Okay, one frame. So since we define the video as the sequence of frames, sequence of images, so basically the images has been arranged from the beginning to the end in order to move, right? So whereby later on we will talk about frame per second. So I'll stop here, then maybe we will discuss in the next slides. Okay, so before that, let's take a look at the two common methods happen in video compression. So normally we could find that the transform encoding happen to be used here is DCT and DWT. So what is DCT? Is cosine. So WT is wavelet. Okay, cos doesn't mean that this one, and the wavelet is, I think it depends on the what they call it, mother wavelet function. Okay, if you guys know about this. So we do have father function. So that would be the idea of DVT and DCT. So we did discuss about this in the early of the chapter that we learned in this particular subject. So DCT is more or less for the JPEG, and this one is for the JPEG 2000. Okay, but years happen, so makes this DVT is reducing the usage in the for the public, while the JPEG is the usage become increase. Okay, so that would be the idea of DCT. So vector quantization doesn't mean that, how to say, encoding a sequence pixel by finding the closest match in a color key. Okay, so in a simple way to describe the vector. So vector is, if we may say, this is vector. So some sort of the representation of vector, we could say that we use the capital of the X, whereby the vector is x1 and x2 and etc. So this is kind of representation of vector. So motion vector, we could see this could be applied when any changes. Example, take a look at this. Take a look at here. We have eyes over here. So then we can see this eye is closed. Okay, so meanwhile the changes is happen to be picked up as a vector changes. So that would be motion vector. Okay, so it's not really talk about pixel, but it's talk about the X and Y. Go on the maths and algorithm situation by looking up the block matching based on the vector changes. Okay, so then the way it happened was like this. Okay, so the first thing first is converting the images for macro block, first step. So and then there would be remember the thing that we did discuss, CBCR? So the one that we have 4, 2, and 2. Okay, so then it goes to the picking up the 8 times 8. So now the idea of transformation is happen here. Okay, so then quantization comes in. So I think you guys still remember what is the quantization means, the idea of changing or digitizing the y value, right? Okay, so then the zigzag style happen to be reading the images by this way, zigzag. So this one is the encoding, the one that we will discuss in the data one, running length encoding approach. So remember we have Huffman, we have Huffman 3 and Shannon coding. So that would be the compression methods. So at the end, before the RLA, they again apply Huffman in order to reduce the number of a bit. Okay, so at the end, this would be transmitting from receiver to transmitter. Yes, okay. To do this, there will be several kind of compression happen here. So the first thing is interframe, like so. Interframe. Okay, let me change the color at first. Interframe meaning comparing between frame to frame. So compress between frame, obviously. So by the words international. Okay, internet. So this one is comparing with other national, this one is other network, right? So interframe, compress between frame over here. So detect how object move from one frame to another. So that would be straight away definition. Okay, now so motion estimation usage method, it's here to calculate the motion vector, encode the differential image along the motion vector. We did discuss over here. So the way that the eyes is moved from open up to the close is basically reducing the difference in vector, okay, as a motion estimation. So encode the differential image along the motion vector. Yes, this is motion vector. So MPEG will be the technology behind the scenes happen to compress one frame to another frame as a video. Okay. Okay, how the interframe compression happens. So basically, since the frame, okay, so the idea of frame per second, I think we always knew about this. I think when we go to the how to describe this camera to take the video, when we press the video down here, we do have photos here. So basically we are allowed to choose the setting, so whereby we can choose FPS per second, things like that. Okay, so this would be the priority of that one. Okay, so frame per second video is high, so meaning 30 frame per second, meaning in 1 second there will be 30 frame, guys, queuing in order to produce 1 second movement, right? Okay, so object does not change rapidly between the frames. So the idea is since we have the frame a lot, so in the middle of 30 frame or even 60, right? So this image, this frame could ever show that the differences between this and those, right? Because it vary 1 second 60 frames per second, so it very huge number, so you can't really see the changes from 1 to 2. So but the thing is, it could be happen when we talk about, okay, let's say we do have, so this is, let's say this is 4 frame in the middle, and then what I did, the changes of frame could be happen between those physically. Okay, right, for this we can say that no change of frame, so meaning less priority in order to compress them, because there will be, it's not talking about the no meaning, but that would be the advantage for us to reduce our information by not looking up the 4 frame in the middle so seriously. Okay, so they are temporal. Okay, object does not change rapidly between the frames, so they are temporal redundancy. Okay, so temporal redundancy means frame to frame, right? So then no need to code each frame, so we don't need to code this and that, so we only code this. this, or we can say, okay, now this and some of those could happen if you want to check. So that would be the things that would be make sense for in our context of discussion, right? In temporal redundancy, the previous frame and current frame are usually similar. So I mean this and this would be similar. So this is not necessary to encode at all. So the encode is the difference happen. So that would be our parity. So how to do just encode the difference is question mark over here. Okay. So to do this, basically MPEG, the motion picture expert group, they call it, suggests the way that they compress a video by looking up by these 5 steps, guys. Okay. So the first is divide the sequence of frame into GOP. So what is GOP here? GOP is group of picture. Group of picture. Okay, there will be S over there. So I think whereby this. Okay. So normally the GOP is up to 15, guys. Okay, 15, meaning there will be one initial start of the group of picture first until 15. So there will be 15 frame considerable to encode them as a group. Okay, so that will be terms of GOP. So relying the 15 frames for each encoding, basically what the MPEG do. Okay, step 2, divide each frame into macro block. So whereby each of the 15 will be divided to the macro block. So the macro means it could be like 16 times 16, 8 times 8, or even. Okay, so the third and the fourth step would be okay. Now this would be the important things. We do have 3 strategies in GOP whereby the MPEG suggests we have 3 categories of frame. So one of those is I. The second and third is P and B. Okay. So remember that I showed you guys just now. This is I, this is B, this is P, right? Okay. All right. So P and B compare the frame to the related I to determine the motion vector or more than one motion. Okay, right. The P and B is basically back and forth. Okay. So record the differential value of P and B. The difference between the expected pixel value adjusted by the motion compensation and the actual value. So the motion compression whereby the pixel happen in the previous frame will be located into the new frame, right? Okay, so then for all the frames that involve in that particular compression, it's not talking about the 15 frame for GOP, so but we talk about 1,000 or million frames in the hands. Okay, so compress the JPEG compression. So yes, then okay, let's take a look at the step number 1. This is step number 1, divide the frame. So how to divide this? Okay, so as I mentioned earlier, I, B and P is basically the 3 frames types in GOP, group of picture. So whereby I stand for interframe, guys. Okay, so F for forward prediction, meaning the forward, and this one is bidirectional, meaning this and that. Okay, so each frame is compared with the closest I or P motion estimation and find the motion vector. So in order to find the motion vector happen in P frame, basically the motion vector is used. Right, okay, I'll change to the red one. Okay, so bidirectional, whereby we do have 2 ideas, back and forward. Okay, so finding the closest I and P. Okay, so both. So P and B are compressed both spatially and temporally. So what is spatially? Spatially means the things that we have frame. So spatially means this area and that area. It's different. So that would be spatial. But it's talking about temporal, meaning this is the subject is falling down, kind of. Okay, so he's basically is falling. And what we do is here, the temporary difference between this frame is standing and kind of before falling situation. So that would be the temporal. Okay, so P and B are compressed both, guys. Okay, so GOP size and the distance between I and P are defined by the encoder. So GOP size is 15 and M is the length 3. Okay, so whereby we can take a look at here is 1 to 15 is the nominal. So the 3 means we could interchange the P to B as 3. So at the normal, so for this time around, we do have 2 over here, 1, 2, 1, 2, 1, 2, and so on, right? So that would be the length. Okay, so to compare the example that I show in this particular slide, we have GOP 15, right? So now, how many that we have? 1, 2, 3, 4, 5, 6, 7. Okay, we have 10, guys. So it could be also 10, but the thing is the I over here and over there. So that would be the in the frame matter. So remember about the this one is the by, right? So this one is forward. So this one is forward, guys. Okay, this one is backward, forth and back. So that's the reason why you can see over here. So this particular arrow, so I think this one is missing. Okay, so it relates that the motion vector is analyzed by looking up to the front. Okay, forward direction. So whereby the B is basically looking up back and forth. So this one. Okay, so that would be the display order, and we can see over here GOP is 10. So the one that I show you just now is GOP is 15, and also the GOP could be 12, guys. So 13 or something. So it depends on the demand of that particular compression methods, video compression methods, right? So step number 2, you remember after we did segregated the GOP to 15, 10, 12, and 13. So we straight away jump to the step number 2, whereby we need to divide the frame, into micro block. Okay, so what is micro block? It could be a 16 times 16, right? Sorry for that. It could be 16 by 16. It could be 8 times 8, depends on the particular compression. So as mentioned earlier, it differs by this, guys. It could be this and that. Okay, so it also refers to the support display transmission. So whereby interlace, or the one that we did discuss last videos, we have the frog picture, remember? So either the line is taken or read to be alternately, or the line is read one by one. Okay, that would be interlace video. Yeah, correct. And okay, the step number 3, the most important step, I think, in the video compression using the motion vector is motion estimation here. So how we do it, right? Okay, so since the motion estimation, and some books write this way, so whereby you could also familiar with this and this, right? So this one is motion estimation, macro block, motion vector, and this one is motion composition. So that would be the abbreviations used in this particular slide. So you can see here and there. Okay, so the most important thing here is in macro block, whereby we can divide this to the each compression B, especially this one is B, because B is bidirectional. It's quite important. Oppositely for F is only forward using this. Okay, so in B, each what is MB? Macro block from B frame will have up to 2 motion vector back and forwards. Okay, this one is step number 1. Okay, so if matching in both direction is successfully, okay, then meaning this one is obviously RGB. This one is both direction, meaning we can take a look at the, how to say, back and forth, right? Okay, right. So the third one is basically averaging. So this one is step 3. And the before comparing the target by generating prediction. Okay, so averaging is the third one. So then the fourth is comparing the target. So meaning, okay, actual minus target. Okay, obviously MB. This one is MB. Okay, the how to call it? The subtraction from the actual MB to the target, we have error, right, guys? Okay, so that will be generating the prediction error. Okay. Okay, so the afterwards, basically the comparison happen. So as I mentioned earlier, so this one is a target. Oh, sorry, target is here. So this one is the previous one. Sorry. Okay. So then this is the average, guys. Step number 3. Okay. So this one is step number 4. Okay, the step number 5 is basically difference block. Okay. So 6 is DCT. And followed by 7 and followed by 8. So that would be the idea of starting from the step number 1 in B frame, guys. It's not F, B. So this method is basically for B frame. So 1, 2, 3, 4. And to get the average between this and this, basically we need to add those two and average them, and we can have the difference. We can have the majority and difference of that particular value, right? Okay, so this macro block is basically refers to this one. Remember the one that we talked about? This. So this is actually the the Chrome subsampling. Okay, so then we split into the 8 times 8 and so on, right? Okay, right. So how they compress in JPEG, basically similar to 261H. So that would be the standard one. Okay, so the target means the target of the frame that we wanted to see, this one. So the reference meaning previous and after. Okay, so compare it and we go to this way. What is this? This is the step number 5, difference macro block. And we need to use this one, remember, 420, 422, 421, and this one's DCT, quantize, and zigzags ordering, and this one is entropy. That would be procedure on B frame. Okay. So in this video compression, I think apart from H261, we do have H231, H263, sorry, upgraded version from 261. Okay, so the lower bit rate, improve motion, guys. So that would be the idea. So this would be kind of interesting. Transmit over the regular telephone line. So meaning it's not even using the fiber optic, but the landline telephone line. Okay. So this is, we have the things related to the compression and the application purposes. So we have filming production, having this maximum resolution is very high. So studio TV is this, and consume tip is only this one, guys. Okay, so that would be the idea. So 261 standard is basically the early digital compression, which happened to be used here in JPEG too, right? So the standard is basically happen when the video phone application comes in. So the bit rates P times to 64 kilobit per second. So where the P is 1 to 30. Okay. So that is that. So we have the luminance. Okay, this one is Chrome. So this one is luminance one. Okay. So we have 88 times 72, whereby the bitrate is 91, and so on. Right? Okay, So just now we did discuss about GOP with 15 frames, right? Remember about that? Okay, so in H.261 standard, basically the idea of I, B, and P and B is different. So because in speaking of GOP for this is not having B, but it's only about I and P, guys. So remember, when we talk about MPEG directly, so we use I, B, and P. So H.261 is only using 2 frames types, whereby we use I and P. Okay, so treat as the independent, similar as JPEG compression just now that we discussed. Only remove the spatial. Spatial mean in frame. Okay, whereby P not independent, couldn't forward predict. Okay, forward, guys. So this will be the keyword here. It's not back and forth, but this one only forward. So that's the reason why we do have only this. Okay, so to avoid the propagation of the codes, I is usually sent a couple times in each second. So meaning in H.261, basically I is injected in second. Okay, so not really meant that all the P must be in the middle. Okay, this one P, but in between the P there must be an I. Okay, so that would be the idea of 261. Okay, this is the video compression, processing and distribution media in the single table. So we do have this NTSC and PAL. Okay, right. Okay, right. So now I'll be continuing about the digital video processing. How we gonna have the processing things happen in the makes a digital video. Okay, so first is shooting. Okay, right. So the second one is gathering, editing, applying special effect, editing sound, apply color. Okay, so those 3 is the time consumed. Okay, so then the rendering, it's slightly how to say, it's okay, but it depends on how is your CPU and GPU in hand. Okay, so whereby if you have a good CPU for your PC processor, that would be fine, and plus if you have a good GPU, and it could be might accelerate your video processing in terms of graphic. Import into the file format with compression. So it is okay, I think, not having a less more times consuming. Distribution is either you using the USB thumb drive or DVD or CD, or you might say that you want to distribute via this platform, or this platform, right? So we will talk about the all the 9 steps in details, right? Okay, right. So the first one is shooting. So the idea of shooting, whereby we need to have the shooting, obviously, the idea of having a camera here. Sorry, this one is a camera. So I need to have a good mic in order to read my voice, kind of read. Okay, so I need to have a screen in order to pull this image to you guys here. This is the image. So that at minimum we need to have the 3 direct tools and sources for video recording. So plus, not to forget, the lighting. So this one is the lighting for clear up my face. So imagine that I close my lamp, so it can be a black area and a dark shadow here. So if you can see over here, this, it might be different, right? So now, example, I am shooting my videos in this small webcam and the screen. So recording, so I need to record from the, let's say, part number 2, video technology. So I record and I do the scripts and I do the how to say, the transition between the frames. I try my best to imagine that what is going to be my final product for the video for part 2. So yes, here we need to connect all the videos and so on, connect the analogs. I go shooting the videos in camera. So not to forget, okay, two more things. One, the one thing is this, guys, the digital pen, and obviously the software. This is the recording stuff. Is I'm using the OBS. Okay, right. Okay, gathering the data time consuming. So the way it is, you need to have a good software to help you. So Adobe Premiere is pricey. Final Cut to the Apple. ULIT Studio could be free and Premiere. So there will be one more thing, DaVinci Dissolve. I think this one is kind of interesting, and Kdenlive. Okay, now I want to show the one that I'm using right now. So the one that I'm using right now is free, open source, Kdenlive. Kden. Okay, I will try to open up to you guys right here. Can you see it? Okay, so now this is the Kden live interface. So alright, sorry, I need to hide the logo, then I try to reduce my shit over here. Okay, so now is this is my videos camera, a webcam live, the way that I'm speaking. Okay, so I put all this input to be in OBS. So the one that I click down there, so they show that this one, right, the logo. So I just unseen them. Okay, right now the way it is, in order to show you guys the videos looks like, so I just open up the one that did in part 1. Okay, so this is the one that, if you guys saw the part number 1 for video tech, is this. Okay, so all the process happened was I did recording 2 times, so straight away from first to 41 minute one shot recording, and the remaining is 5. So because this kind of because I need to have a pause and things. Okay, so so I did upload to the software, and we have the intro mp3 and intro, outro, and outro. So you might see that this one, if I play this one. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from. So that one is outro, and this one is intro. So this one is free from copyright stuff. So I already signed the agreement and so on, including this one. So this one is the okay, sound, end sound, outro. This one is the intro sound. So basically you need to have many things to be done. So this one is the raw one. Hi, assalamualaikum, and very good morning everyone. So today I would like to discuss about our new topic for multimedia technology. And okay, remember that I said to you just now in this video, the time consuming happened here. Okay, I'll show you. Imagine that you just hear the videos, right? Hi, assalamualaikum, and very good morning everyone. So today I would like to okay, now today I would like to say that is discuss about. Okay, then again I did so that would be not necessary for listener and viewer. So what I did, we need to cut them. So the way that it is, basically this is the one that I've been doing. So the idea is to pull every single thing audio. This is the audio, this is the video, and then I bring here, so you can see the way that it is. Can hear. All right. Hi, assalamualaikum, and very good morning everyone. So today I would like to discuss about our new topic for multimedia technology and application. on the digital video technology. So now basically I did cut those video sequence into some pieces, right? 1, 2, 3, 4. So in order to avoid the things like that, so that would be very kind of time consuming for me. I cut them. Example, okay, I'll cut them to, okay, let's say I want to cut here, right? So I need to cut them and I need to delete this part. Example, if we take a look at here, display technology, at that moment I just only say so that would be not important for the viewers, right? So you may delete them. So then you pull it back here, so you can hear like this: video and film display technologies, and so without right? So yeah, so that would be the idea of looking up the editing from the sound, videos and so on. So then finally, the way it is, okay, so capturing videos, clip, and importing, so that would be the one happen. Sequencing, the one that I show you just now, I trim my voices, okay, and again to trim the time. Fade in and fade out is basically the one that I do here. So the fade in and fade out is just a matter of this. So you can have a fade here. Okay, let's say fade out over here. I put here. So you can see right down here. Okay, I play this song. I play this clip. So you can see that this powerful beat sound will be reducing. See, they will be gradually going down. And very good morning, everyone. So that will be the fading. And then transition can be applied, clips and timelines, fading out, fading in. So that would be transition is easy, guys. So based on the K, you can just play this thing. You just go here and you just stick down there. So you can, how to say, hold on. You can play with this thing. Okay, you just take a look. That would be multimedia technology, and so that would be the digital stuff, video technology. So if you want it, right, get started. So you can just play around with this. That would be time. Basic effect, changing shape and so on. Drama key. Okay, key is interesting. Chroma key and mid. So that would be another section to be discussed. I think I skipped this one. So that would be the most interesting parts to discuss. Okay, effect, shape and positioning, I think it's easy. You may go to this one, project bins, and you just put it there. Okay, title, okay, this one could be, so we have this one, let's say salam to all. So you can play around with this. You just put, sorry, this way here. All right, sorry. Okay, become this color. So you can do the underline and so on and so forth. So then you create the title and you just pull over here. So then it becomes, that would be the manual editing, right? Compared to the apps kind of. This is salam to all. Good morning, everyone. So today I would like to, so right, that would be the thing. Okay, so then I think the blending was a interesting task, alpha, mid and chrome. So that would be the most challenging things in preparing. Okay, so then in the matter of distributing, basically, okay, render. Okay, right. So after you did every single thing happen until the outro kind of. So where's the outro? Okay, this is the outro, guys. Sorry. Okay, this is the outro, right? So I mean you have the outro and then 6. Okay, thank you guys for watching NMZ. Okay then. Hopefully, so then you think that the video almost finished. So you go to project and render. So render is talk about to save, to rendering. So to finalize all these changes to one single file as, okay, let's say MP4 and things, render to video tag to where the output is. Okay, so after you rendered it, let's say I press this one, so there will be waiting time at least 30 minutes and so on and so forth. So I just cancel this job, right? Okay, then I close this one and I close. So that would be the whole process of myself editing the videos. Okay, right. So we have the video distribution as AVI. So the one that I used just now is MP4, guys. Share. So that would be common for YouTube. Makes things easier. Okay. So I think that's all my sharing for the video processing and technology. So I hope you guys can rewatch this video again and again for the subject of BENC 3443. Okay, thank you and see you in the next video. Bye. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.